Topic B, methods in classes. Now, I was going to title this just methods, but there is a distinction between your normal method and a special thing called class method, and then both of those are in the class. So I'm also going to use this other term, instance method, to distinguish it from class method. But generally, if you hear people talking about methods, these are the methods that people are talking about. Class methods and their use is very rare. So, let's have a think about what these are. Essentially, these are functions. They're written just like functions that exist in a class. Each instance of that class, each object, has access to those functions. Let's have a look in a little more detail about how they work. So as I said, these are methods or functions, and every instance of an object can perform them. They may change or use the attributes of that object. Now, if well written, these methods often define what I would say are the rules and regulations for what you can do with the attributes of the object. You generally call them by object name followed by instance method. So if there are parameters here, you would put the parameters, and you would put actually open closed brackets. And when you write them, you will notice something. It's a function. It looks just like a function, but the first parameter, which is actually ignored, is the class itself. So with no further ado, let's have a look at them in code. So back to our class person, you have this initialization of name, age, height, and centimeters. There they are. These are the three attributes. So this is the first method we're looking at, speak. You notice the self here, and you do not put self there. As I said, the self is ignored. So when you say Adam.speak, it's going to just execute this function. And it's going to execute it not just for Adam, it's going to execute it for any person object, because every person object has the attribute speak. So let's just look at an example of a more advanced method. First here, then we're going to look at it in code, the same one. So this is a method that has two person objects interacting. So it takes in a person, another person object as a parameter, and it actually checks their name, and if the name is Rogers, it'll say, hey neighbor, else print, and then it'll print hi person dot name. Alright, let's have a look at that in Python. So I thought that the person method greet from that slide required a little bit more of an interactive explanation. So because we've already written functions that greet people, you might have the idea that, for example, let's say we create a person object. So we're going to need Bob is a person, and Bob can be, I don't know, obviously his name is Bob. His age, I don't know, Bob can be 33. Height in centimeters, I don't know, 1/8. Control Alt L. So now we have Bob, and Bob has the greet method. But the greet method has a wrinkle, person dot name. So Bob can greet, well, not just anybody. If we say Sally here and attempt to run this, all kinds of errors. String object has no attribute name. So this is the string, and the Sally.name means nothing. Now, if Bob would greet Bob, I think that would work, because Bob's an object, but it's kind of, he's greeting himself. So really, to have this greeting thing work properly, you need to have another person. So that could be Sally, and her name would be Sally, her age would be maybe 35, 160. So now Bob can greet Sally, and he'll say, hi Sally. So this is a very, very interesting example, because you really do require multiple objects for this program to make any sense. And you can kind of see that methods can often be designed to interact with other objects. So in this program, we are going to continue working on the car class. And what we're going to be doing is we're going to be adding new attributes and adding a method which in this case interacts and sort of shows you how to use the attributes that the car has. Now the new attributes we're going to be adding are going to be speed and max speed, one of which is not going to be set via a parameter. See, I figure, let's say we're at a car yard. Let's say the car is not going to be anything other than 0 when the car is created. So we're just going to assume when cars are created, they're created stationary. Whereas max speed is obviously an attribute of the car, which can whatever. So let's get started. The first two are relatively straightforward. As I said, max speed is going to be set via a parameter. So we can say comma max speed, and we can create it, self dot max speed equals to max speed. And as I said, you do not have to actually write anything as a parameter. If you want to create an attribute, you can just say self dot speed and set that to 0. Car has an attribute speed now. No problem. So you'll notice that this code, which worked last time, is probably going to give us an error message because we do not have max speed. So we can just add it. It's 220 kph. And so you have your car dictionary here. You'll notice speed is there, even though it's not a parameter in the init function. So let's have a think about how we want to create the accelerate method. Well, the first part is easy. Accelerate. First argument is always the self. Then, what do we have any arguments? I'm gonna say that we can have an add speed argument. That should be set to a default. So if you just accelerate, open close brackets, car.accelerate, you should change your speed by 5. You can car.accelerate 20 if you want, but there's a default acceleration, which is set to 5. So here, we can basically say self.speed, so should increase by 5, and that we can just use the iteration, plus equals to 5. So as you can see, plus equals to, not 5, add speed, because we can add any amount of speed. So as you can see, we are introducing a couple of new concepts, the first of which is an attribute which is not specified at the init arguments, and the iteration of an attribute right here. So let's try to use the accelerate method. So here I'm printing my car dictionary, and I can basically say my car dot accelerate. Now, I expect speed to be 5 because it's increasing by 5. I can accelerate by 20, and then I can accelerate by 25. This should be 45. This should be adding, and it is. So the accelerate method works. However, there is a glitch. So let's say for the sake of argument, I'm going to do a lot of acceleration. So I'm going to accelerate 10 times that much. Speed is 450, and that should be impossible. So what you could just say here, something along the lines that the speed can never exceed max speed. So you could check if speed has exceeded the max speed and then only iterate. However, you may never reach the max speed. So let's say if you won't iterate when you're trying to add 20 to 210, you will never reach 220. So it makes more sense to do the check here. If self.speed is greater than self.max speed. Now, if that's the case, what does the speed have to be? Well, it has to be the maximum speed right here. So you could basically assign self.speed equals to max speed. Or, don't forget, self.maxSpeed. After all, max speed is an attribute of your car object. So if this works, this is now going to be whatever the max speed is at initialization. So right there, that's going to be 220. Run it, 220. So just for the fun of it, we can test this out with the dream car. Remember the dream car, the DeLorean DMC? So we're going to say dream car. It's going to be another car object. That's DeLorean. It was DMC 1983. It's about 1.2 tons. Wasn't as fast. 180. So let's say now we got this DeLorean, and we're going to accelerate and print the DeLorean. And we're going to just double check that the speed that it's limited at is the DeLorean's max speed. Run it. Bingo. Beautiful. So that's it for this lesson. I'll just reiterate what we covered. We added max speed and speed as attributes of the car. Max speed was set via the init function. Speed was automatically set to 0. Then we created this method, the accelerate method, that iterated speed and also limited speed to max speed.